everyone, welcome you all in our YouTube channel Learning Radiology. Then start our today's topic. Today we will discuss on the topic interaction of X-rays with matter. So these are the topics. In this topic we cover about 5 types of interaction of X-rays with matter. Means X-rays come from a X-ray tube or X-ray emit from a X-ray tube. After emitting of X-ray from X-ray tube, they interact with any type of matter or like patient or patient tissue. Then what are the process to be occur after interaction? So there are 5 types of interaction in X-rays. So firstly, see about what is the introduction of interaction of X-rays with matter. So X-ray photon firstly interact either with the orbital electrons or a nuclei of an atom. In the diagnostic energy range of the interaction are always with the orbital electrons. If these electrons are one bonding atom into nucleus, then the bond is disturbed and the nuclear structure is altered. Molecular binding energy are too smaller to influence number and types of reactions. Sometimes X-rays are absorbed and sometimes are scattered. When scattered, they are deflected into random courses and don't carry any type of information. They add noise to the film, which is called as a film fog. Type of interaction: coherent scattering, photoelectric effect, Compton scattering, pair production, and photodisintegration. Firstly, we see first one is Compton coherent scattering. Coherent scattering is also a type of interaction. These are the first interaction called coherent scattering used in a diagnostic radiology. In coherent scattering, radiation undergoes a change in the direction without changing a wavelength. So this reaction also called as unmodified scattering. There are 2 types, Thomson and Rayleigh scattering. In Thomson scattering, single photon is involved in the reaction. In Rayleigh scattering results from a cooperative with all electrons of an atom. Only one type of interaction between X-ray and matter that does not cause ionization. To produce an ion pair, photon must transfer energy to atom. No energy transfer and no ionization occur. Less than 5% of coherent scattering occurs throughout the diagnostic energy range, and it never play a major role. These are the images which show coherent scattering. Here images shown that radiation changes direction but without changing their wavelength. So radiation come changes their direction without changing their wavelength. Second types are photoelectric effect. Photoelectric effect. In photoelectric effect, when the incoming photon that transfer all its energy to the orbital electron and removes it from an atom. Parts of its energy is used to eject the electron from its shell and rest given as K and Ke2 electron. Photoelectric process involves bound electrons from K cell, L cell, M cell or N cell. Ejected electron is called photoelectron, and the incident photon must have sufficient energy to overcome the binding energy of electron. Photoelectric effect. Photoelectric reaction is more likely to occur when the photon energy and electron binding energy are nearly same. It is inversely proportional to third power of energy, and tighter the electron is bound in its orbit, the more likely is to be involved in reaction. Photoelectric effect is proportional to third power of atomic number of absorber. Images show photoelectric effect. Here images show the Incoming photon transfer all its energy to the orbital electron and removes it from atom. Electron come and removes it from atom, and these are the structure of an atom. Photoelectric effect application to diagnostic radiology. It's had good effect or bad effect. Good effect is like to produce good quality image, not producing scatter, and enhances natural tissue contrast. Contrast is good when difference in absorption between adjacent tissue is large. Bad effect are like patient receives more radiation dose, all incidence photons are absorbed. Third is Compton scattering. In Compton scattering, incident photon with relatively high energy strikes a free outer shell electron and eject it. Photon is deflected by electrons so that it travels in a new direction as scattered radiation. Reaction produces an ion pair, a positive atom and a negative electron, which is called recoil electron. The energy of a photon is distributed into two ways. Part of it is given as a kinetic energy to recoil electron, and rest of is retained by photon. Here image show the Compton scattering. An incident photon at relatively high energy strikes a free outer shell. Electron strikes in a free outer shell electron and it's eject out. Photon is deflected by an electron so that it travel in a new direction. Electron energy out and it travel in a new direction as scattered electron. Compton scattering, it is independent of atomic number, and it is very important in the range of 60 keV to 60 kilo electron volt to 5 mega electron volt, as it accounts for most scattered radiation encountered in diagnostic radiology. Energy retained by the photon is dependent on the angle of deflection of a recoil electron. Another types are pair production. This does not occur in diagnostic energy range. High energy photon interact with nucleus of an atom and photon disappears. The energy of a photon is converted into two particles, an electron and a positron, which have the same mass of an electron. Mass of an electron is equal to 0.51 mega electron volt, so does not occur with photon energy less than 1.2 mega electron volt. Our images show pair production. Here the probability of a pair production increases with the energy, and second power is the atomic number. First one is energy and second is the atomic number. Another types are photodisintegration. Here the interaction between a high energy photon and nucleus of an atom, and the parts of nucleus is ejected by high energy photon. Ejected part may be neutron, proton or an alpha particle. Photon must have sufficient energy to overcome the nuclear binding energy in order to 7 to 15 mega electron volt. They do not have any importance in the radiology. Thank you. Comment on video, subscribe the channel, like the video, press bell icon.